Alright, today we are going to be covering dependent events. Go ahead and pass up your homework, copy the word walk vocab. We're going to take notes, do some examples, and the homework is going to be on the back of your daily work. Excuse me. Alright, let's go and review what we've been doing so far. We've been talking about the theoretical probability, um, calculating what our theoretical probability is for certain events. Yesterday we talked about independent events. If I roll the cube and if I spin the spinner, I have two independent events that I'm working with, and I'm trying to find the probability of those two things happening side by side. Alright, today we're introducing a new word and a new manipulative called a bag of marbles. Some of you guys recognize it from last year. Go ahead and copy that down on your note-taking guide. And the keyword is dependent. Alright, yesterday we had a bag of marbles. Let's just say I have a bag of marbles and there are 6 green marbles and 2 blue marbles. Okay? When an event happens, for example, the event is the probability of pulling a blue, if you do not replace the marble back into the bag, you have a dependent event because it changes any future events. So if I take out a blue marble out of here, what does the 2 turn into? My new bag will now be 6 green, and now I will only have 1 blue marble. So the next event that I calculate will have a different denominator in the fraction. So the probability of a blue and the probability of pulling another blue goes like so. The first probability is 2 out of 8 because there's 8 total marbles. Now I can reduce that to 1 over 4, and the probability of pulling out another blue, if I do not replace, is the following. Now I have this new bag right here, and I'm going to have to calculate my new probability. I know that now there's 1 blue marble out of a total of 7 marbles. Now I can calculate my probability for these 2 events happening. 1 times 1 is 1, 4 times 7 is 28. Okay? So this right here is what's going on with dependent. Notice that my denominator changes with my dependent event. Alright, that's the only word and set of words today is the bag of marbles. Alright, let's go ahead and get out your notes and copy this problem. I will give you some time to copy the problem. You can push pause if you need to. Okay, the situation is there's a bag of marbles. 1 is red, 1 is blue, or 3 are blue. The problem is, what's the probability of picking a red marble, not replacing it, and picking a blue marble after that? Okay? Well, let's dissect this sentence and pull out the math. The probability of picking a red marble is what? Well, I see that there's 1 red marble out of a total of 4 marbles. So that right there, I pulled the math out of my sentence into that. Okay, keywords right here, not replacing. I'm not going to replace it. So what happens to my total number of marbles? If I took a marble out of the bag, this 4 is going to turn into, or not turn into, but my new fraction is going to only have 3 marbles. Okay, and what's the probability of picking a blue after this? So I already picked my red, I took it out, now I have 3 marbles, and they happen to be all blue. So I have 3 out of 3. This is kind of a strange one, but always be prepared for what you're going to see. Okay, so my fractions have changed, but the way of doing it, because I have this word and, has not changed. The and, remember, again, becomes multiplication, and I'm just going to multiply straight across. 3 times 3, or 3 times 1, gives me 3. 3 times 4 gives me 12. I'm going to reduce it. 3 goes into 3 once, and 3 goes into 12 4 times. So my probability is 1/4. One way you should get used to looking at probability is events. This probability right here is an event. It's event 1. And then you need to ask yourself, the other event, which is this one right here, now let's just write down, this first event is the probability of a red. The second event is the probability of pulling out a blue. But nonetheless, it is another event. So we have event 1 and event 2. Now, the difference between what we did yesterday and what we're doing today is that we're doing a little subtraction. Our 4 is going to change into a 3 because we're taking out a marble. Let's go ahead and turn to your daily work and look at question. Look at the question that has number 1 and 2. All right. So our bag of marbles has now changed. We have 3 red, 2 blue, and 2 green. And notice I put marbles are not replaced. That's very important. Okay, so let's get acquainted with our bag first. How many total marbles do we have in the bag right now? Well, we got 3, we have 2, and we have 2. That's 7 total marbles. Okay, you always want to keep your total on the tip of your tongue because you're going to need that number. All right, what is the probability of pulling a red and green marble? All right, let's just take the first one. The probability of pulling a red marble is 3 out of the total 7. Okay, remember, I am not replacing that marble, so I need to figure out the probability of pulling a green marble now. Yes, it's green. The probability of pulling out a green. Well, how many greens are there? There's 2 out of how many total marbles? Well, this total right here has changed because in theory I pulled out a red marble. So in theory, if I pulled out a red marble, now it's turned into 6 total marbles. So now my new total is going to be 6. Now we can calculate the probability of this event happening. I'm going to look real quick to see if I can cancel out anything top to bottom or side to side. And I do see that this 3 right here, I can divide 3 into itself and get a 1. And I can divide 3 into 6 and get a 2. And that also opens up another opportunity for me to reduce 2 over 2 into 1 over 1. So always check to see if you can reduce anything side to side, top to bottom. I could have also done 1 to 3 and it would have canceled out diagonally. But either way, you're going to get 1 over 1 times 1 over 7. So that makes my life easier. 1 times 1 is 1. 7 times 1 is 7. So my probability of getting a red, not replacing it, keywords, and getting a green is 1 out of 7. All right, let's go ahead and look at the next one. So I have, what is the probability of pulling a red and a blue? Well, we already figured out the probability of pulling a red first because it was in this problem. So the probability was 3 over 7. Okay? And now I'm going to pull out a blue. But remember, my total has changed. I just pulled out a red marble, so now I don't have 7 marbles anymore. I have 6 marbles in there, in theory. So how many total blue marbles I have? I have 2 over 6. Well, we have a very similar situation. We're going to multiply these two. See if I can cross out anything. Let me do it the other way. I have 2 over 6. This is going to turn into 1 over 3. And I can cancel out the 3's. And again, I'm going to have 1 over 7. All right, go ahead and go down the page and go down to number 10 and 11. I'm going to have the same number of marbles, except it's a different situation. Okay, and let's just refresh. I have 3 red marbles, 2 blue marbles, and 2 green marbles. You always want to keep track of your totals when the problem says marbles are not replaced, or you see that the events are dependent on each other. All right, so the first one says, what's the probability of not getting a green? Okay, remember, I'm not replacing any marbles. Okay, so let's look at the probability of not getting a green. Well, the probability of getting a green is 2 out of 7. So what's the flip side of this fraction? Remember, there's always 2 parts of a fraction, what you have and what you don't have. So the flip side to this fraction is 5 out of 7. Now in theory, if I pulled it out and didn't replace it, I'm going to figure out what my probability is again, except with a different denominator, of not pulling a green. Well, now I have a new denominator, which is 6, and I just decreased that 5 into a 4 because I took out a marble. So now I'm going to multiply those two. And before I multiply, let me go ahead and reduce anything. This I see can reduce to 2/3. Cancel that out. And nothing else can reduce. So let me go ahead and multiply across. 5 times 2 is 10. 7 times 3 is 21. And I can't reduce that anymore. All right, little review. How do I turn this into a decimal? Again, all your problems, I expect the decimals and the percentages. Okay, remember, in over out, the 10 is going to go in the box. 21 on the outside. Do yourself a favor. Write yourself some lines that separate the problem. All right, so we're going to draw our lines. I forgot my 21. So Draw a line that separates your 1, your 0, anything else, and cover up. Cover up the 0 and the 10. Ask yourself, does 21 go into 1? Answer's no. Don't forget to bring up your decimal. Haven't done it yet. 21 cannot go into 10, so put another 0. Now you bring up your decimal. Sorry. So this is 0, 0. Again, the zeros are just reminders to help you figure out where the division problem is going. A lot of you are just being sloppy with your work, and you're missing your decimal where it should be. I'm going to add a 0, 21 into 100. How many 21s fit into 100? Well, I know 5 20s fit into 100. This is a little more, so it's got to be 4. 4 times 21 is 4, and 8. All right, and so we need to borrow here. And we're going to borrow 1. 10 minus 4 is 6. We're going to borrow here. 9 minus 8 is 1. We got 21 into 160. I know 20 goes into 168 times, so it's got to be a little less. It's going to be 7. Okay, so we have 0.47. In order to turn a decimal into a percent, we're going to take 0.47. Remember, you're at a decimal, you want to go to a percent. You're at a decimal, you want to go to a percent. It's Dr. Pepper, 2 times to the right. So it's 47%. Okay, this last one. What's the probability of not getting a red, and not getting a red, and not getting a red? I'm going to set this up, and I'm going to walk around and see how you guys solve it, and then solve it on the overhead. So the probability of not getting a red is, well, let's look at the probability of getting a red first. The probability of getting a red is 3 out of 7. So the flip side of the fraction, not 3 over 7, 4 over 7, that's the first event. And I'm just going to decrease the number by 1 every time because I'm taking out a marble and not replacing it. So this turns from 4 to 3, and this turns from 3 to 2. And this is 5. All right, now this is where you can really help yourself by doing some cross simplifying. I can see that 3/6 can turn into 1/2. Okay? I can see that 2 and 2 can turn into a 1. And nothing else cancels out. But now I have 4 times 1 times 1, which equals 4. And now I have 7 times 5, which equals 35. And I have my fraction there. And if I want to turn it to a decimal, I'm going to put the 4 in the box. 35 goes on the outside. I'm going to line up my rows. I'm going to put my decimal up top. Add a 0. Can 35 go into 40? Yes, it can once. I'm going to subtract. I get 5. Can 35 go into 50? Yes, once. It's 0.11. And the percent is 11%. And the decimal, again, it's 2 times to the right. 1, 2 to go to a percent. 11%.